What's up everybody and welcome to a new video. And in this video we're going to go over my notes for the debugger in VS Code. And here first I want to clarify some terminology. Namely, I want to show how I define bug, debugging and debugger. So bug is simply a technical error or malfunction. Then debugging is the process of fixing technical errors and malfunctions. And a debugger is a tool that allows you to execute a program one line at a time, and therefore then you can inspect its state at any given point. So what the values of variables are, for example, or what functions or classes are available and things like that. And this is then obviously useful for debugging. Okay, so this is how I define those terms. Okay, so now let's get to the second point, which is about the basic functionality. And here, just as a side note, the specific available functionality depends on what programming language you're using. So I'm using Python, for example, and if you're using something different, there might be small differences. Okay, so now let's see what those points here looks like. And the first one is about setting breakpoints. And here I want to talk about first the purpose of breakpoints. Namely, therefore, I've prepared here this file. And here, let's say you're interested in this list variable after it has been populated in this for loop here. So you are interested in this variable at this point here in the program. So now, instead of starting at the first line of the program and then going through it line by line until you reach this point here, you can simply create a so-called breakpoint. So by hovering here over the gather, you see this red dot, and then with that you can then toggle on or off the breakpoint. So then what will happen is that the debugger simply executes the program until it hits that breakpoint, and then you can inspect its state. So that is the purpose of breakpoints and how to create them. Okay, so then the next point is about the Breakpoints View. And it is this view here at the bottom of this debugger section. And what it does is it lists all the breakpoints of the workspace. So for example, if I open another file, and then here if I add another breakpoint, then you see that it gets listed in this Breakpoints View. And this Breakpoints View here lists the file name. So here these two breakpoints are in basic functionality.py and file1.py. And then after that, it lists the location of the file if it's not in the root folder. So file1 here is in the root. So therefore, there's no location listed, and basic functionality is within demonstration examples debugger. Okay, and then lastly, here at the end, it lists the line number. So on which line the breakpoint is within that file. So here it's on line 5, that's why it says here 5. And then if you click here a breakpoint in this breakpoints view, then VS Code simply jumps to that respective breakpoint. And then here you also have a checkbox, and with that checkbox you can deactivate the breakpoint instead of deleting it. So if it's deactivated, then you have this gray circle here. And then here, if you hover over a breakpoint, you have these this toolbar here with these options. So the first one is to edit condition. And this has something to do with the advanced functionality that we talk about in the next video, namely about the different types of breakpoints. Okay, and then here with this X, you can simply remove the breakpoint. And then lastly, here is the toolbar of the breakpoints view. Here, the first option, you can add a function breakpoint. And again, that is one of those different types of breakpoints. Then after that, you can have a toggle to activate and deactivate all the breakpoints. And here, as you can see, this doesn't affect unchecked breakpoints. And then lastly, here you have an option to remove all the breakpoints. So those are my notes that I wanted to cover with respect to the breakpoints view. Okay, so now let's get to the next point, which is about running the debugger, i.e. starting it. So therefore, to show how that works, I've prepared another file here. And here let's set a breakpoint at this line, so line 12. And then let's go back here to the debugger. And now to start the debugger for this file, simply click this Run and Debug button. button. So then here this opens first this drop-down list, and here you have to specify a debug configuration. And again, this has something to do with this advanced functionality here, namely the launch configurations. So we will cover that in a later video. Okay, so now let's simply here choose the configuration Python file, and then the debugger starts. And the first time you do it, it might take a little moment before it actually starts. And you can then verify that it is running when this status bar here turns orange. So now it's orange, and you can see that the debugger is running, and what it did is it executed this program until it hit this breakpoint here. And then it paused the program, and it's indicated with this yellow arrow here and this yellow highlighting. And here, however, this line here is not executed yet. So if you look here at the terminal, for example, here we can see the first print statement, start program, and then here it printed out 1, 2, and 3. However, it didn't print out end of program yet. Okay, so this is how you can start the debugger. But here I also have some side notes, and the first one is that you can start the debugger alternatively via the menu bar or the editor play button. So here, for example, if you go to the menu bar to run, here you have the option to start debugging, or here in the editor toolbar next to this play button here, you have this drop down arrow, and here you can use this command Python debugger debug Python file to start debugging. Okay, so that's the first side note. The second one is then that the breakpoint must be set on an executable line. So it shouldn't be set on an empty line or a line with just a comment. So what then will happen is that the debugger will put those breakpoints on the last executable line before that breakpoint. So for example, this breakpoint will be put on line 10, and this breakpoint will be put on line 5. So let's start the debugger to see that. So now if I start it, then you can see that those breakpoints jump to those respective lines, and if I stop it again, they go back to their original positions. Okay, so that's the second side note. And then lastly, here a side note states that you can actually also run the debugger without setting any breakpoints. So if I turn those here off and then start the debugger, then you will see that the status bar turns orange for a short moment. So then what happens is the debugger simply runs through the program, but doesn't pause it. And you can see that it runs through it by these print statements here. Okay, so those are the side notes that I wanted to cover. And with that, now we've covered all the points that I want to mention with respect to running the debugger. Okay, so then the next point states that you can execute a program one line at a time via the Debug Toolbar. And this quote here refers back to our definition of a debugger, which was that a debugger is a tool that allows you to execute a program one line at a time. And in VS Code, you can do that via the Debug Toolbar. So now let's have a look at that. Therefore, let's go to this file and here set breakpoint at line 6 and 18, and then start the debugger. And here you can see the Debug Toolbar, and you have these different actions here available. So the first one is to continue, and what this does is it simply the debugger then simply continues the execution of the program until it hits the next breakpoint. And the next breakpoint can actually be the same breakpoint. So for example, here in this for loop. So if I press this button here, then you can see that the debugger continued executing, because here now it printed out the 1. If I press it again, then it printed out 2. And if I press it again, then it jumps to the next breakpoint. And then if there is no other breakpoint after that, and if you press then continue, then the debugger simply continues to program until completion. So if I press it again, then you can see we have these other print statements, and the debugger stopped. Okay, so that is the first action that you have available in the Debug Toolbar. Then the next action is called Step Over, and what this does is it executes the highlighted line and then goes to the next line in the current scope, i.e. it doesn't go into functions, classes, or modules, for example. So to show you that how that works, let's put here a breakpoint on line 10. and then start the debugger. So here is this option, step over. So if I now click that, it simply goes to the next line. And here, when we call this function, it doesn't go into the scope of the function, but it simply stays in the global scope and goes to the next line. So if I click it, you can see we just go to the next line. And here the same thing with the class. So it doesn't go into the class, but simply to the next line in that current scope. And then also here with this module, it doesn't go into the module, but stays in the global scope. However, then here there's one exception, namely if there is a breakpoint somewhere in the debug scope, then it actually jumps into that debug scope. So to show you that, let's stop the debugger and let's add here a breakpoint in this function definition. Then here a breakpoint in this class, then a breakpoint in this method, and then some breakpoints in this my module here. So therefore let's open that file. And here let's put a breakpoint in this function definition, and then here when this function is initiated. Okay, so now let's start the debugger and see what happens now that we have these breakpoints in those debug scopes. So now if I step over, so here we call this function. So previously when there was no breakpoint, we just went to the next line here. However, now since there is a breakpoint, if I step over, we jump into that function. So now let's step through that. And then here, again, when we call this function, we jump into the function. Then here in this class, previously we just jumped to this line, but now since there is this breakpoint, we actually go into that class. And here again, we call it the square function. So therefore then we jump to that. And then we go through the class here. And then here when we call this method, we jump into the method. And then lastly, here on this import my module line, since we add here in this my module here on line 4 a breakpoint, because of that now we jump into that module. So let's step through that. And then here when we call function 1, since there is a breakpoint in function 1, then now if I step over, we also jump into function 1. Okay, so these are the notes that I want to mention with respect to step over. Okay, so then the next action is called step into. And what this does is it goes into the scope of functions or methods, classes or modules. This is applicable when a function or method is called, when a class is defined or a module is imported. So to show how that works, let's stop the debugger here and delete all those breakpoints. And then let's set here a breakpoint at line 10 and then start the debugger again. Okay, then now let's get to this line here where we call this function. Now, if you want to step into this function, we can simply use this step into action. So now we are in the function and then we can step over the lines within that function. And then what you also can do, you can step into a class. So here the class is defined. So if you want to step into that, then now we have stepped into that, and we can see this here in the Callstack, and we talk about the Callstack in a moment. So now let's step through the class. Then here, where we call this a method, we can also jump into that. So again, let's step through it. And then here, this module, we can also step into that module. So let's again step through. So this is how the step into action works. And here I also have a side note, namely if there is no scope to step into, then step into behaves like step over. So for example, if we stop the debugger again and then start it again, then here on this line there's nothing to step into. So now if I click step into, it simply steps over to the next line. So those are the points that I wanted to mention with respect to step into. So then the next action is called step out, and that executes the remaining lines of the current scope and returns to the outer scope, i.e. you don't have to step over each individual line of that current scope. So for example here, if we step into this function definition, then instead of stepping through this whole function here, we can then simply step out of it with this action here. And obviously this would be more useful if this function definition here would be very long. And then here, there's also a side note, namely if there is no out of scope, then step out behaves like stop here. So if I here, there's no scope to step out of, so this is already the global scope. So if I step out of that, then the debugger simply stops. Okay, so these are the nodes that I want to cover with respect to step out. And then the last two actions are restart and stop. So restart, simply as the name says, restarts the debugger. So if I start it here and then step over a couple of lines, and then now if I restart it, then it restarts the debugger from the beginning. And this again takes a moment before it starts. And now it has restarted from the beginning. And then here stop, with stop you can simply stop the debugger. So those are the main actions that you have for the debug toolbar. So now let's go over these side notes here. And the first one is that the continue button also serves as a pause button. And to show you that, I've prepared here some code. So let's put here a breakpoint on this line and then start the debugger. And now let's run this code here. And now, as you can see, as this program is running, this continue button turns into a pause button. So with that, you can then pause the program regardless of any breakpoints. And there's some peculiarity with that. Namely, if you pause it in this way, then you can't inspect the state of the program. And to get around that, you simply need to step over one line. So then the variables view is populated again. Okay, so that's the first side note. And the second one is that you can move the toolbar left and right and up and down with this handle here. So you can move it around, left to right and up and down. And the lowest possible point down is right below those tabs. So those are the side notes that I want to cover. And with that, now we've covered all the points that I wanted to cover with respect to using the debug toolbar. Okay, so the next point mentions that you can inspect its state via the different views. And again, this refers back to our definition here, that you can inspect the state of the program at any given point. And in VS Code, you can do that via the different views. And those views are the variables view, the watch view, and the Callstack. So let's go first over the variables view. Namely, what that does is it displays the program's current variables. And those are then broken down into global and local variables. So to show you that, let's go back to basic functionality. And here let's set the breakpoint at line 14. Then run the debugger, or start the debugger. And then here in the variables view, you can see those local and global variables. And here, just as a side note, if you are in the global scope of the program, then local variables and global variables are actually the same. So now here, if we step into the square function, then you can see now they are actually different. And we have here number 2, which is this parameter. And if I step over here one line, then we also get here this result variable. And now if I step out of this function again, then you can see that the local and global variables are again the same. Okay, so then the next point is about the different types of variables listed in this variables view. Namely, they are special variables, basic variables, function variables, class variables, and modules. So to see those in action, let me stop this debugger here, and then let me set the breakpoint at line 4 and then start the debugger again. Namely, then we can see here first there are these special variables, and special variables are not directly part of the program itself, but they are built in directly into Python. So for example, this would then include here this __ name variables, or some built-in functions like for example this len function or this print function. So those are special variables. Then next there are what I call here basic variables, and now here if I step over a couple of times, then you can see now we have here these variables. So those are the actual variables that are part of the program itself. And here, just a side note, if there is a data structure, then you can further inspect it via this drop-down arrow here. So here you can see that, for example, this has 3 elements, and here are those 3 elements with the respective index. So those are basic variables. Then next there are function variables. So here we are about to define this function. So let's step over one line. And then now here we see this function variables entry. And here's our square function. And here I also have a side note. Namely, when a function is called, the return value is also listed. But this is only the case when you use step over or step into and out and not continue. So for example, now here, if I step over this function call here, then you can see here the return value of square is 4. And this also works for step in and step out. So if I step here into this function and then out of it again, then you can see here the return value of square is now 9. And with continue, you don't see this return value. So for example, to show that, let me put here a breakpoint, then stop the debugger and start it again. And then we're gonna jump directly from this breakpoint to this breakpoint with this continue button. And here you can see there's now no return value listed. Okay, so those are function variables. Then next there are class variables. So therefore, let's here again step over this line. Then we can see here are the class variables, and here's our sum class. And here again I also have a side note, and this says that when a class is initialized, the return value is also listed. So as you can see here the return value of some class is none. But again, this is only the case when you use step over and not continue. So in this case here I used step over. So now let's see what happens when we use continue. So therefore let's again put a breakpoint here and delete this one, and then stop the debugger and start it again. And now if we jump from this breakpoint to this one with the continue button, then we don't have again this return value. Okay, so that's our class variables. And then lastly, there are also modules listed. So for example, then here we are importing my module. And now if I step over that, then we have here our my module. And here are then functions 1 and 2 of that module. So those are the different types of variables that are listed in this variables view. Okay, so now let's go over these side notes here. And the first one is about the inline values. Namely, the values of the respective variables are also directly depicted within the file. And namely, you can see this here with this yellow highlighting. And this is done either where the variable was assigned or where it was last referenced. Okay, so then the next side note is that you can hover over a variable in the file to see its value. So for example, if I hover here over this list, then we get this information. If I hover over the X, then we can see it's a 9. If we hover over the square, then we get also here this information. Okay, so that's that side note. The next one is then about the toolbar of the variables view. And here you only have this collapse option. So if I unfold here some of these variables, then you can easily collapse everything by pressing this button. Okay, so that's that side note. And the last one is about right-clicking a variable. And to show that, let me stop the debugger again and then remove those breakpoints. And then let's set the breakpoint here at line 15 and then start the debugger. And then here, what you can do is you can right-click a variable. So for example, if I right-click here this X, then you have these options here. So you can set the value. So currently it's at 4. So for example, let's set that to 0. Now the variable is 0. And now if the program then prints out this X, then you can see it actually prints out 0. So that's the first option that you have. Then here you can also copy the value or copy the expression. And this last option here is to add the variable to the watch view, which we're going to talk about next. Okay, so those are the side notes. And with that, now we've covered all the notes that I wanted to cover with respect to the variables view. So now let's get to the watch view, and what that does is it enables you to more easily keep track of a specific variable or expression. So for example, if you step through your program, then the variables view can get somewhat cluttered, and then it can become difficult to keep track of a specific variable. And with the watch view, then you can easily see, for example, then always see what the value of X is. So that's the purpose of the watch view. So now let's go over the toolbar, and here you have a button to add an expression, and here you can really add anything. So for example, let's add the square of X. You can also call here functions from your program. So for example, let's call the square function. So if we say square of X, then we also get 81. And you can also call, for example, methods. So let's call a list method here. So let's call list.count, and let's count how often the 3 appears, and it appears once. And here then if you right click an expression, then you can also edit it again. So let's say we don't want to count the 3, but we want to count the 1. This also appears once. Okay, so that is this first button here. Then here you also have a button to collapse all, and then here you have a button to remove all expressions. And as a side note, you can also just hover over a specific expression and just delete that. So let's now remove all expressions. And with that, we have now already covered all the points that I wanted to mention with respect to the watch view. Okay, so now let's get to the Callstack view. And what that does is it displays the order in which the program's subroutines were called. And the current one is at the top. So to show that, let me here again stop the debugger. And then let's put this breakpoint here at line 22 and then start the debugger. And then here in this program, let's step into the class. And then here, let's step into square. So now here is the Callstack, and the information that you get here is the name of the function or class that was called, or here when you're on the global scope, then it simply says module. Then here next to that you can see the file name, and if I make the sidebar a little bit bigger, then you also see here the line and column number. And if you click here on entry, then you get to the respective subroutine, and it's then highlighted with the screen highlighting. So for example, here in the module, so in the global scope, at line 22, we then jumped into some class, and then here for some class at line 23, we jumped then into square. So that's where the Callstack is currently at. And here, just as a side note, if you right click here on entry, you can copy the Callstack. And in the toolbar here, you also have a button to collapse all. Okay, so those were all the points that I wanted to mention with respect to the Callstack. So then lastly, let's get to the side note here, which is about the overflow menu. So this one here at the top. And here you can simply toggle off the different views, toggle on or off the different views, or you can toggle the Debug Console. And with that now, we've covered all the points that I wanted to cover with respect to the different views. Okay, so then let's get to the next point, which is about using the Debug Console. And as you can see, the location of the Debug Console is here in the panel. And the purpose of it is that it lets you interactively write code based on the program's current state. So to show how that works, let me here again stop the debugger and put a breakpoint here at line 15. And then start the debugger. And now here, let's go to Debug Console, and now let's write some code based on the program's current state. So for example, this list here is already initiated, and we have here access to it. So if I print it out, you can see it then here. You can also use here this function, the square function. So if I say square of 5, then we get here 25. And however, if I now try to use here this sum method call, then this doesn't work, as you can see, because this instance is not initiated yet. So let's step over some lines to create that instance. And now it's initiated, and now we can actually call some method. Okay, and here just as a side note, you can actually just write any code. It doesn't have to be related to the program. So for example, if I type 1 + 1, then here we get the result that this is 2. Okay, so this is one of the purposes or one of the use cases for the Debug Console. The other is that it displays messages from log points. And again, log points are one of the topics here on the advanced functionality. Namely, it's one of the different types of breakpoints. And we will cover that in the next video. Okay, so that's the purpose. Then the controls for the Debug Console are as follows. If you want to run code, simply press Enter. If you want to get to a new line, then you need to press Shift Enter. So for example, if I write here for I in range 5, range 5, and now if I press Enter, then we get this error because it tries to execute this code. So if you want to then get to the next line, you have to press Shift Enter, and then here you can write the print statement. So if I execute that, then this now works. And then here with the tab, you can then select entries from member lists. So if I type something here, then I can here go to the member list and then press tab to insert that. And then lastly, with the up and down arrow keys, you can cycle through the command history. So if I press here the up arrow key, then we get to the previous commands. Okay, so those are the first points that I want to mention. Okay, so now let's get to the toolbar. And here you have this input field, and this is for filtering debugging output, i.e. this is for filtering messages from log points. And again, those will be covered then in the next video. Okay, then here you have a button to clear the console, and here you have then a button to search across the console. So to show how that works, let me here step over a couple of lines. And then let me here add some statements. So we're going to use square 5, and then my module function 1, then my module function 2, and then function 1 again. Okay, so now if I click this button, then we get here the search window, and here you can type in your search. So for example, if I search for my, then you see that these results here are highlighted, and you can use the arrow keys to cycle through those matches. And then here you have these two search options. The first one is to filter. So if I turn this on, then only the search results are shown. And here, just as a side note, if I, for example, search for funk, then you can see that only these expressions here are highlighted and not this output. However, if I apply the filter, this nonetheless considers the output as well. Okay, and then we have here a fuzzy match. So if I turn this on and search, for example, for func_n, then we can see that we have here the search results. And if I turn it off, then there are no results found. Okay, so with that now, we've covered all the points that I wanted to cover with respect to using the Debug Console. Okay, so now let's go over the side notes here. And the first one is about multiple debugger sessions. Namely, you can run multiple sessions simultaneously. So right now we have only one session running. However, let's now here start, for example, a session for file 1. So then here in the editor toolbar, simply click debug Python file. And then you can see here now there are 2 sessions running. And this takes a moment again to get started. And then the way that you can switch between those 2 sessions is here in the debug toolbar. You have this drop down menu where you can switch between those. So if I go here to file 1, so now I can step over for this session, and if I go back to the other session, then here I can also then continue to step over. Alternatively, you could also use these debug toolbars here in the core stack. And then here also in the Debug Console, you now have a drop-down menu where you can switch between those 2 different sessions. So these are my notes for multiple debugger sessions. So then the next note is about non-workspace debugging. Namely, you don't have to open a workspace to use the debugger. So for example, here I've prepared a file that is opened not in a workspace. And here if I start the debugger, then you can see that this is also working. However, the only difference here is that in that case, you can't use launch configurations. You can only use them when a workspace is opened. Okay, so now let's get to the last side note, which is about the just my code setting. So to show how that works, let me just stop those debugger sessions. And then here I have prepared some other code. So let's paste it into this file and let's set the breakpoint here at line 7. So then let's open the settings and look for that setting. So settings, and then here search for just my code. And by default, this setting is enabled. So by default, the debugger only considers user code. So for example, if I then here start the debugger for this file, then if I now try to jump into or step into this rand-int function, then this doesn't work and it simply goes to the next line. However, if I disable the setting here and then start the debugger, then I can actually jump into rand-int, so into random.py. Okay, so that's the first difference that you have when this setting is enabled or disabled. The other one is then related to the call stack. So for example, if I enable that again and set here a breakpoint at the 8 and transform this 10 into a string and then start the debugger, then you will see that we get here an error and the call stack, however, stays in our module. And now if I stop the debugger again and disable the setting and now I start it again, then you can see that the call stack actually goes into the library code. So if I click that, I again get to the random.py file. Okay, so that are my notes for the just my code settings. And with that, now we've covered all the notes that I wanted to cover with respect to the basic functionality. So in the next video, we will then go over the advanced functionality. So thanks for watching and hopefully I will see you in the next video.